Alright, so let's finish this unit with objective 7.3. We're going to find missing angles of right triangles using trigonometry. Again, we're going to be using SOHCAHTOA, and you should notice that these problems look very similar to the ones from objective 7.2. The difference is that what we're looking for is an angle and not a side. So we're going to start the same way. In this case, in our first example, our reference angle theta is unknown. So that's the question mark. You can put a theta or an x. I'm going to do this one with the theta. This just means I don't know what it is yet. The opposite side is the one that is across from theta. So that's the leg 10. Our adjacent side is the leg that is next to theta. So that is that 33. And then the hypotenuse in this case is that long side on the bottom, and we do not know what that is, so we'll just scratch it out. Now we have to decide what trig we're using, sine, cosine, or tangent. Opposite and adjacent in this case only go with tangent, so we have to use tangent. And now we set it up the same way that we did in the last couple of objectives. So I'm going to write tangent of the angle. Now I don't know what this angle is, but I have to write something, so I'm going to write theta. Again, you can be writing x if you prefer, if you don't like the Greek letter theta, is equal to opposite over adjacent, so that is 10 over 33. And what you should have just practiced was how to get an angle, how to solve for an angle when you have a trig equation where that angle is inside of a sine or cosine or a tangent. So what you should know by now is that to solve for that angle, you have to use the inverse trig. So that looks like this. The angle is going to equal inverse tangent, which is written tan with a little -1, of the ratio that was on the other side. So this should look very, very, very similar to other inverse operations you know. The theta was on the left, it stayed on the left. The 10/33 was on the right, it stayed on the right. The only thing that changed was the tangent that was on the left became inverse tangent that was on the right. This is one step, and we are now ready to finish because theta is by itself. So we're going to write theta is equal to, and then we're just going to grab the calculator to type this in. Again, whichever calculator you are using, make sure that it is in degrees, or it will give you a wrong answer. So inverse tangent of 10/33 comes out to be 16.86. And since we found an angle, we do have a unit of measurement. That's got to be in degrees. And that's basically it. We have a second example, but this example is not going to really be different than the first one. It's just going to be some extra practice. So let's get started with that one. Again, we have a reference angle that we do not know, so I'm going to write it as x this time, just for fun. Across from that angle is that leg, which is blank, so we will not be using opposite in this problem. The adjacent leg is 24 in this case, and then the hypotenuse is the 36. So now I need to decide which of these three trigs I'm using. So I've got adjacent and I've got hypotenuse. That only can be cosine. None of the others have adjacent and hypotenuse, so this problem will be a cosine problem. So we will set it up. Cosine of the angle, and the angle right now I do not know, so I'm going to write x or theta or whatever you're writing, is equal to, this is cosine, so cosine is adjacent over hypotenuse, so that's 24 over 36. And if you're asking yourself, does that reduce? The answer is yes, but also it doesn't matter because we're going to be using a calculator in a moment anyway. So whether or not you reduce it, it's not going to make a difference in the final answer. So the next step is that we're going to get x by itself by doing inverse cosine of 24/36. Again, x stayed on the left, 24 over 36 stayed on the right. The cosine on the left became an inverse cosine on the right. We're going to be done in a second. I'm just grabbing my calculator and typing this in. Inverse cosine of 24 divided by 36, close parentheses, and I got 48.19. And again, since it's an angle, I have to put a degree symbol. Again, unlike the last objective, these two examples were essentially the exact same. This objective does not have the same variety of problems as the last one. And with that, we are done. We have found missing angles of right triangles using trigonometry.